differentiation of two vectors. If both A is a function of u and B is a function of u or vectors, then the following conditions should be satisfied. So these are the properties for any differentiation. So d by du, A plus B, individually we can differentiate. So dA by du plus dB by du. Then d by du, A dot B will give you, first you have to keep this as it is, A dot dB by du plus dA by du dot B. For cross also it's the same thing. So d by du, A cross B will give you keep as it is A, then dV by du plus dA by du cross B. Okay, so these are the properties. Now we'll try to solve one problem. So F is given as, so it's a vector field. See, earlier you just remember this is a scalar field. So you have to differentiate these two. It's a scalar field. There is no I, J, K here. So it's a scalar field. You have to differentiate both. But here it is, it's a vector field. So a vector field is given as, so vector field means there must be a vector, okay? The vector is missing here. F equals 3u v squared I plus 2u squared minus vj plus uq plus v squared k times. We have to find out d partial df by du, d squared f by du squared, df by dv, d squared f by dv squared, and we have to find out this d squared f by du dv, then d squared f by dv dv. We are going to find out all those things. So f is given as this. Now we are going to differentiate with respect to u. Here u and v both are variables here. See, u and v, they are function. F is a function of u and v. See, f depends on u and v. F is a function of u and v. Is it okay? Now we have to differentiate with respect to u, keeping v as constant. We have to keep v as constant. We have to differentiate with respect to u. Now we will differentiate with respect to u. So when we are going to differentiate with respect to u, will give you 1. So 3v squared. So 3v squared I. Okay, correct? Is it okay? And what are the differentiating with respect to u? 4uj. This becomes 0. There is no u here. Differentiating this will give you 3u squared plus 0. So differentiating with respect to u will give you this. Again, when I am going to differentiate this with respect to u will give you, this becomes 0. There is no ith component. So this becomes 4j. Okay, when I differentiate this will give you 6u. So this is d squared f by du squared. Okay. Now df by dv. So we are going to differentiate with respect to b now. When I am going to differentiate with respect to v, will give you 2v, correct? 2v. So that will give you 6, already 3 is there, so 6uvi. When I want to differentiate with respect to b, this becomes 0, this becomes minus 1, so minus j. With respect to b will give you, this becomes 0, so this becomes 2v, so 2vk. D squared f by dv squared will give you, with respect to, again we have to differentiate, that will give you 6u times I. Here that will give you 0 and this becomes 2k. So d squared f by dv squared is nothing but this expression. Now we have to find out d squared f by du dv. We know already df by dv is given by this. Correct? See, we know already df by du is given by, df by dv is given by this. Now what is asked? You have to differentiate with respect to u. So when you are going to differentiate this with respect to u, will give you this. Here it is df by dv. What is asked? D squared f by du dv is asked. So when you are going to differentiate this with respect to u, will give you d squared f by du dv. So when you are going to differentiate this with respect to u, will give you 6v, and this becomes 0, this also becomes 0. So we have 6vi. And the last one is t squared f by dv du. Already we know that t f by du, already we know. When you are going to differentiate this respect to v, will give you d squared f by dv du, which is equal to, with respect to v you are going to differentiate. So this becomes 6v, 0 and 0. So answer will be 6vi. Look at the expression, look at the value here. This also 6vi and this also 6vi. So right hand side are equal, so left hand side must be equal. So d squared f by du dv equals d squared f by dv du. So that's all, very important one. Okay. Now directional derivative. So we have come to the next one, directional derivative. The formula for directional derivative is nothing but d phi by dx. This is nothing but del phi, which is equal to a unit vector del phi. So this is the formula. We are going to substitute this formula and get the results. So the component of del phi in the direction of vector A is called the directional derivative of phi in the direction of A, which is given as del phi dot A cap, which is equal to del phi. This A cap is nothing but A vector divided by mod A vector. Okay. So here it is A, so this must be capital A. Okay. But doesn't matter, and this formula that we are going to use, del phi by dx equal to a dot del phi, so which is the directional derivative. We'll solve one problem, then we'll discuss the ideas. Compute the directional derivative of this. Okay, at the point 1, 2, minus 1 in the direction of the vector, this is given. So first the formula, as I said, formula is this one. Okay, del phi equal to a dot del phi. So del phi equal to a gradient phi. Okay, that's called grad phi, gradient. Okay, gradient grad phi. So first we will calculate del phi. Del phi is nothing but d phi by dxi plus d phi by dj plus d phi by dz k vector. Okay, your phi is given as this. So instead of phi, you will have to substitute this. Okay, here phi is a scalar function or a vector function? Phi is a scalar function. There is no I, j, k. So this is a scalar function. So del phi. Okay, del phi is given as this expression. So phi is given as this, and del phi is given as this expression. So your del phi, you will find out del phi. Del phi is nothing but d phi by dx times I. So first we will differentiate with respect to x first. So now when differentiate this with respect to x, that will give you 2xz plus 2y squared plus 0. When I differentiate this with respect to y, will give you 0. This will be 4, 2 times 2y. So 4 times xy, and this will give you z squared. When I differentiate this with respect to z, will give you x squared. This becomes 0, and this becomes 2yz. Del phi at 1, 2, minus 1. Del phi at 1, 2, minus 1. That's the problem in the problem. So del phi at 1, 2, minus 1. Wherever you find x, you substitute 1. Wherever you find y, you substitute 2. Wherever you find z, you substitute minus 1. Will give you this. Simplifying will give you 4 plus, you have 4 here, correct, and you have 2 multiplied by minus 1 will give you, and this is 1 minute, z equals, you have z equals minus 1, correct. So 2xz, x is correct, z instead of s minus 1. So that's wrong here. It must be 2 multiplied by minus 1 will give you minus 2, correct, minus 2. So it's correct only. So 2 2s are 4, 4 multiplied by 2, 8. So 8 minus 2 will give you 6. So it's correct. So 6i. And here 4 2s are 8. Minus 1 squared plus 1. 8 plus 1, 9. So 9j. And here it is 1 multiplied by 1 plus. So that will give you minus 4. So minus 4 plus 1 will give you minus 3. So minus 3. So your del phi is given as this. And what about A vector is given as this. So your A vector is given as this. So take modulus A vector will give you. See, the formula is like this. You have to find out mod A. You have to find out mod A. So A is given as this. So root 2 squared plus 3 squared minus 4 squared will give you 4 plus 9 plus 16 will give you root 29. So this divided by this will give you A by A. Okay. This divided by this will give you A by mod A. So your A is given as A by mod A, which is equal to 2i plus 3j minus 4k divided by root 29. So root 29 is given as this. So this is your directional derivative. The formula is directional derivative is given by this. So you have a dot del phi, where a vector is given as this, where del phi, this is your del phi and this is your a vector, correct? So we will find out now. This is your a, this is your a, del phi is given as this. So now I dot I will give you 1. So this multiplied by this. So 2 divided by root 29 multiplied by 6. And this j dot j, you have to multiply only with the ith component with the ith component. So I dot I, j dot j, k dot k. So 3 divided by root 29 multiplied by 9. Then this will give you minus 4 divided by root 29 multiplied by minus 3. So simplifying will give you 12 divided by root 29, 27 divided by root 29 plus 12 divided by root 29, 12 plus 27 plus 12, that will give you 59. So this is your directional derivative. The value of the directional derivative is given as 51 divided by root 29. So directional derivative. Okay. Calculate the directional derivative of the production x, y, z, which is equal to xy squared plus yz cube at the point is given as this 2 minus 1 1. The directional vector is given as this. The same formula, we are going to use the same formula, del phi equal to del phi dot a vector. So that will give you a cap, that will give you del phi a vector divided by mod a vector. So grad phi equals, this is your del, this is your phi. So del phi is nothing but this. Okay, del phi is nothing but this. So del phi is over now. What about a? A is given as this, I plus 2j plus 2k. So this is your a. So before that, directional derivative of 2 minus 1. So wherever you find x, you substitute 2. Wherever you find y, you substitute minus 1. Wherever you find z, you substitute 1. And you will get this. Okay. So directional derivative at 2 comma minus 1, 1 is given as. So 1 is given as, you have I minus 3j minus 3k dot, this is your a vector, see a vector divided by mod a. Mod a is given as root of 1 plus 4 plus 4. So which is equal to, you have to have a dot product. So that will be 1 multiplied by 1 minus 3 multiplied by minus 2 minus 6 minus 3 multiplied by minus plus 2, that will give you minus 6. So 6 plus 6, that will give you minus 12 plus 1, that will give you minus 11. So 11 by root of 4 plus 4 plus 1 root 9, answer is 3. So minus 11 by 3. Okay. Now in what direction from the point 1, 3, 2 is a directional derivative, phi is given as this, is maximum. What is the magnitude of this maximum? So we have to find out the maximum value. In what direction? So we are going to use the same formula. Let us see. Del phi is given as del, phi is given as 2xz minus y squared, and so that will give you I2z minus j2y plus k2x. So that can be simplified as 2zi minus 2yj plus 2xk at the point 1, 3, 2. So wherever you find x, you have to substitute 1. Wherever you find y, you have to substitute 3. Wherever you find 2, z, you have to substitute 2 here. So substituting, that will give you this, and this will be your grad del phi at the point 1, 3, 2. Now magnitude of grad phi will be, just find out the magnitude. So that will give you root of 4 squared plus minus 6 squared plus 2 squared, that will give you 56. You have find out now magnitude of grad phi. Okay, so this is the maximum value, 56. Find the directional derivative of phi, x squared minus 2y squared plus 4z squared at 1 comma 1 minus 1 in the direction is given. It is asked in what direction is the directional derivative from the point is maximum and what is its value. So as usual, this is your del phi. Phi is given as this, it's a scalar function, and you have grad phi is given as this. So del phi at this point 1 comma 1 minus 1 is given as, instead of x you substitute 1 here, instead of y substitute 1 here, instead of z substitute minus 1. So you will give this, you will, and this is a vector, a cap, so that will give you 2i plus j minus k, if it's given as, see 2i plus j minus k is given as this, divided by mod a, so divided by mod e. So which will give us 2i plus j minus k divided by root 6. Root of 2 square plus 1 square plus 1 square. So that will give you root 6. Directional derivative is nothing but this multiplied by this. So that will give you 2i minus 4j minus 8k dot 2i plus j minus k divided by root 6. So 2i multiplied by 2i. So that will be 2 2s are 4. Say 2 2s are 4. I multiplied will be 1. Minus 4 multiplied by 1. So that will be minus 4. Minus 8 multiplied by minus 1, that will be plus 8. So this is 8 divided by root 6. What is asked? The direction derivative is maximum along the normal in the direction of grad phi. So which is given as the maximum direction derivative will be just take the mod of del phi. So that will give you 2i minus 4j minus 8k. Take the modulus, will give you 4 plus 16 plus 64, which is equal to 84. Find the directional derivative of f equals x square plus y square plus z square in the direction of the vector I plus 2j plus k at the point 1 0 minus 1. So this is your surface is given as x square plus y square plus z square. First find out del f. So del f is nothing but del f. So del f is given as this. Okay, so you have this. So del f equals I, instead of here you substitute x square plus y square plus z square. Instead of here substitute x square plus y square plus z square. Similarly here also. Now you will differentiate with respect to x. So this becomes 2x plus 0 plus 0. 0 plus 2y plus 0. 0 plus 0, 2z. So your del f is given as this. What is asked? Directional derivative of this point is asked. Vector is given as this. A vector is given as this. So you have a vector divided by mod a. So we have I plus 2j plus k. See, I plus 2j plus k. So divided by root of 1 square modulus. So root of 1 square plus 2 square plus 1 square under root. So that will give you I plus 2j plus k divided by root 6. The formula is this one. Del phi equals del f is equal to del f dot a unit vector. So you have del f is given as earlier we calculated, this is your del f. Del f is given as this, and your a by mod a is given as this. So with the dot product that will give us, 2x plus 4y plus 2j divided by root 6 at the point 1 0 minus 1. So wherever you find x you substitute 1, wherever you find y you substitute 0, wherever you find z substitute 1, will give you 4 divided by root 6. So almost same formula, the answers. Find the directional derivative of f equals xy plus yz plus xz in the direction of the vector. So a is given as this. So f is given as this. We are going to use the same formula, del f. Find out del f now. But here it is, f is nothing but xy plus yz plus xz. When I am going to differentiate with respect to x, will give you y. This becomes 0. This becomes z. So y plus z. This becomes x, and this becomes z. This becomes 0. There is no y here, and this also will become y plus x. So your del f is given. Your a is given as this. So your a is given as this. The same method. A is given as this divided by taking the modulus will give you root of 1 square plus 2 square plus 2 square, 4 plus 4 plus 1, root 9, so 3. So your del f multiplied by a vector divided by mod a will give you this answer. Substitute at the point 1 2 0. Substitute wherever you find x 1, where you find y as 2, where you find z, you have to substitute 0. So you will have 2 plus 0 plus 2 plus 1 0 plus 2 times 2 plus 1, that will give you 10 divided by this. Okay. Find the directional derivative of f equals 2xy plus z square in the direction of a vector I plus 2j plus 3k at the point 1 minus 1 3. So f is given as this. Del f equals the same formula. So you have this. Now instead of here we will have to substitute 2xy plus z square. We will have to differentiate with respect to x. Will give you 2y plus 0. here it is 2x plus 0, here it is 0 plus 2z. So this is your del f, and a is given as this. So you have to find out mod a will give you root of 14. So directional derivative along the given direction is given as del phi dot a vector divided by mod a will give you this expression. So you will have 2y plus 4x plus 6z divided by root 14. At the point 1 comma minus 1 3 will give you this expression. The answer will be 20 divided by root 14. Find the directional derivative of 4x squared z plus x y squared z at the point 1 comma minus 1 comma 2 in the direction this one. So what is the formula? The directional derivative is the same formula, del phi dot a vector divided by mod a. So your phi is given as this, it's a scalar field, and del phi is given by this expression. Okay, so instead of phi you substitute here, we have substituted here, and you will differentiate with respect to x. When I want to differentiate with respect to x, will give you you have 4z into 2x, correct? So we have 8xz. See, 8xz. See, when I want to differentiate 4x squared z, that will give you 8xz. So we have 8xz. See, 8xz. Correct? And here y squared z. So y squared z. What is jth term? When I want to differentiate y, that will be 0. And here it is 2xyz. See here 2xyz. When I want to differentiate this with respect to z, will give you 4x squared. Here it is xy squared. See, 4x squared plus xy squared. Now del phi at this point 1 comma minus 1 comma 2 will give you this. Instead of z, you have to substitute 2 here. See, substitute 2. Instead of x, you have to substitute 1. Similarly, you have to substitute for y, you have to substitute minus 1 will give you this. Okay, so simplifying will give you 4 2s are 8, 8 2s are 16, so 16 plus 2, and here it is minus 4, correct? Minus 4, and here it is plus 5, so 5k. And this is your del phi at the point 1 comma minus 1 comma 2, 1 comma minus 1. So del phi is given as this, and of course a is given as 2y minus a plus 3k. We have to find out mod a, so that will give you 4 plus 1 plus 9 root of 14. Formula is del phi dot mod a divided by a divided by mod a will give you 18i minus 4j plus 5k, and this is given as 2i minus j plus 3k a vector divided by mod a is root 14, and you have to substitute for the values are given as 1 points are given as 1 minus 2 you substitute will have 18 multiplied by 2, okay, 4 multiplied by minus 1, 5 multiplied by 3, so that will give you 36 plus 4 15. So adding all those things will give you 55 divided by root 14.